Hello, everyone. Good morning, good evening. Welcome back. Welcome to Cloud and DevOps Batch 58. So before I start the session, I just want to give a quick recap on what's being covered in the previous session. Previous session, it was taking time when we try to deploy this. Okay, this is because of the fact when you run it for the second time, it is failing, saying that this name already exists. That's fine. So you can just ignore that and proceed it. Okay, it's going to deploy the ingress controller and the Prometheus stack. Once the Prometheus stack is deployed, so what I did was I just went KC get SVC and I got the endpoints. Okay, and I copied this and I updated the DNS record. Okay, so that I can access it from the external network. So I came here and I updated the cloud apps.today and went and said grafana.dev, okay, which is the same name that we have given for applying this. If you look at this Prometheus dev, we have given it as Grafana dev, so we can access it from the external network, which offers HTTPS out of the box. Okay. All right. Perfect. Now you can also see it is secure. Now what I would like to do is I would like to deploy the images. So what I would like to do is I would like to make some dummy commit. Goes to front end, and I would like to call this as some dummy change. Okay. Done. CD to expense front end. Done. Likewise, go to the front end and in the db config, the Docker file, and then next.js, I'll just say run section, which is going to make the deployment automatically. If you come here and if you try to see, you can see front end would be invoked, and you can also see the backend is going to be invoked. And the reason why it's failed is I just attempted to rerun the same image, and if the image is already in place, it's not going to rescan the image on the top of the ECR. There is a limitation. Now, once the application is deployed, what I want to do is, okay, what I want to do is I would like to deploy Prometheus and Grafana on the top of EKS. Yes, that's done. Next, I would like to, okay, whatever the metrics that are offered on the top of this, okay, whatever the metrics that are offered on the top of, whatever the metrics that are, whatever the deployments, front end, back end, which is being deployed on the top of this EKS cluster, I would like to ship the metrics, including the logs. Okay, I would like to ship the logs of these containers to ELK stack. Okay, since it is a database, I don't want to take a risk of placing them on Kubernetes because it needs a separate management. Since we already have the ELK stack, I would like to stick to this now. And then whatever the metrics like CPU saturation related metrics that I want, I would like to I would like to send it to Prometheus and Grafana, which is available on the top of the same. Okay, now since this Prometheus Grafana and all of them are on the same instance, you should be able to see them. Okay, let's see how to get that. Okay, and again, we would like to implement observability for golden signals, which we'd like to start with this. Okay, so first let's see whether it is completed or not. It's still going through. It's uploading the image. Scan and decide. That's right. Now, what is the password? I think admin, if I'm not wrong. Admin password or admin. Okay. What could be the password? Okay, all right. Since this is deployed on the top of the Kubernetes, you should get them as a secret. Okay, let's go ahead and try to get the secret, and you should be able to see. So, get secrets-a. For Grafana also, you should have a secret. Prometheus and Grafana, get secret. You should get a secret admin user, and this is the password. Okay, echo. Okay, prom operator is the password, and what is the user? And the user is this. Okay, admin and prom operator is the password. Okay, done. sign in. You should be able to sign in. Okay, and the connection. Now, if you go to the connections, okay, data sources, okay, so you get most of the information from here itself. Okay, so I can just come here and just say localhost. Okay, you should get everything. Okay, because since it is everything available locally, what I can do is I can go and say what information is needed for me. Okay, so these are metric dashboards that are coming out of the box with this Prometheus stack. So I just want to go here and I would like to say what all I need. Okay, so here is where I would like to spend more. But on the project one, we have already did enough on saturation. I don't want to go back again. So what I would like to do is I'll just come here and I'll try to see what best we can do. For example, if you are interested about cluster resources, like, okay, what is the CPU utilization? What is the memory utilization of the compute? Okay, so compute resources at the cluster, you can come here and select this. Okay, you got it. Can you see this? You got most of them. So all you need to do is you can just save it. Okay, I want this information in the frequency of last 15 minutes. Okay, so which information are you interested? Nodes, workloads, pods. Okay, whatever it may be, you can get it. Okay, this is one thing. Or if you are interested about, okay, if you are interested about container workloads, like what is the CPU and memory utilization of the workloads, you can select, okay, what you can select is compute resources pod. Okay, compute resources pod, okay, compute resources pod. What you can do is come here, you can just say, okay, whether you want data on the top of the Prometheus or you want the information on the top of this, which application are you interested about? Whether are you interested about this, you can always mention. Okay. So why my front end, back end are not showing up here? Because you're in the Argo same space. Okay, so the data source is default and I'm interested about default, and within the default, okay, you have your front end, back end, and all these things. Okay, so where is my front end? Where is back end? Why my front end is not coming up? So first let me see, is it really deployed or not? So backend is deployed. Okay, my front end, why it is deployed? ECR scan, limit exceeded, the quota per scan per image. Okay, fine. Let me go here into the ECR. Okay, let me delete these images. Let me try to make an image. So come here and try to see the front end. It would have been triggered. Let's wait. Should be able to seeing it deployed. Let's wait for it. Let's wait. Let's wait for this to get deployed. It's getting deployed. Let's wait. Okay, I think it got deployed. Okay. Let me go here and try to access it. Expense.cloudapps.data. Perfect. My application is also working. Now, if I try to make 150 insurance. Okay, done. Now application is working. Now if you come here and if you try to see this, okay, the default and namespace is this, or namespace is default namespace. I am interested about the front end. You should be able to see the front end workloads as well. Okay, now front end workload is very less because it just came up now. Okay, so it's going to take up some time. If you come here KGP, you should be able to see the front end workloads as well. You can see front end, it just came few minutes. So for every 120 seconds, it goes and fetches the metrics. So if you wait for some time, it should go and get. Okay, let's wait. Okay, it should show in some time. But if you're interested, you can come here and can mention it. Or if you're interested about something else, okay. So namespace at workloads level or namespace pods or compute resources workload. Okay, you can also see all workloads. Okay, what is the overall workloads of everything? You can come here and say default. Okay, what all workloads are there? Everything you can come here and can define which workloads are you interested. This is makes more sense because it comes up at deployment level, which is very nice thing. Okay, for example, if you're interested about the backend, you can come and see what is the CPU utilization of it. Okay, this is the CPU utilization, and you can also mention the refresh interval is 5 seconds. And if you have any quotas defined, you can. Okay, so what is the memory usage of it? You can define it. Okay, so everything would be coming up. Okay, with respect to the pod. All right. For example, if you are interested about how your front end is doing, you can select the same front end just came up recently, right? Last 5 minutes, you can come here and see how CPU utilization, memory utilization, everything is coming up out of the box. So I really don't want to spend more time on it. Okay, that's my intention. I just added it as my front. I just added it as my uh, what do you call my favorites. Okay, so if you want, all I want is I'll just come here and I direct to see it. Okay, so I am not much interested about CPU memory because they are coming out of the box. Okay, so here is my next interested aspect. Saturation, we are good because you're getting out of the box. So I don't want to comment much on it. Next thing is latency. Okay, so latency, what is the response time of the front end? What is the overall response time? I want to see how things are going on inside it. Okay, and I also want to see how many requests are coming up. Okay, and out of the requests, how many are errors, how many 500 errors are there? I just want such kind of information. So for that, what I need to do is I need to have this information coming up from a different. Okay, how can I do that? Okay, so for that, I need to ship the metrics from here to. Okay, I need to ship the metrics from here to ELK. So for that, I need to start my ELK machine, ELK stack. So let me try to start my ELK. Okay, I think I have started my machine. So let me try to access the ELK stack. You don't have to memorize the ports because we have configured a reverse proxy for everything. I think it's coming up. Admin and password. What is the password? I don't remember. Let me go and check the vault. Infra secrets, ELK. Okay, this is the password of my ELK. Let me sign in. Why I'm not able to sign in? This is interesting. ELK password. Forgot ELK password. ELK reset password. How come? So Beats connecting to Logstash and Logstash sending the details. Okay, in all the expense app, go here. The file wait, task, main.yaml. Okay, and it says file wait.yaml, and in the file wait.yaml, okay, it says elk dot expense dot internal. Okay, fine. So username is equal to elastic. Okay. Okay. So the username and password are elastic. Okay. All right. It's been a while, so I forget that. Okay. So what I would like to do is I just want to create elk username as well. Elk username. Elk username. What is that? Elastic. Come here and let's try to keep it local as well. That's it. Okay, now I'm expecting all the logs to be showing up here. So if you come here, if you go to the stack management, okay, in the index management, you can see the logs, okay, ECS, Elastic Cloud, okay. And if you see these logs are, when these are coming up, these are from 26.9.39, but they are not the latest one. So what I want to do is I just want to make a refresh, okay, and I want to tune my workloads, okay. Now, here is how we need to do. So we need to understand one thing, okay. So next thing is we need to deploy file beats, and then we need to tell the file beat, okay, these are the logs that needs to be coming up extracted from this particular point, and then you need to send it. Okay, so you need to understand where logs will be coming. Okay, so 02-DEC. Okay, on EKS, where logs of the containers are going to be stored. Okay, on the path, on the server's path, where log containers. Okay, so based on the type of the container, all the logs, okay, that are running on the top of the EKS, they are going to run on the top of it. Now, what we are going to do is we are going to install, okay, we will deploy a set called as, I'll deploy a daemon set for file beat. defining the log stash as endpoint. Okay, so guys, are you aware of this daemon set? Girisha, Harish, Mahendra, Rachit, Shailaja, Shrilata. How many of you are aware of it? So typically when you are having a cluster with multiple nodes, okay. Okay, so let me try to show this. Okay, for example, let's take this as an image. Okay. So for example, if you take each and every node, okay, now you want to deploy something. Okay, so you want to deploy a workload that should extract the metrics from each and every node and it should send it to somewhere. Or your intention is you want to make sure on the top of our cluster, on the top of each and every node, each and every pod should be running off a set. Okay, for example, I want to make sure I want to extract the logs from this container, this node, and this node. So you want to make sure whether your cluster upsizes or downsizes. I want to make sure a pod of the set should be deployed automatically so that it is going to do the job of logging or monitoring or whatever it may be. If you want a minimum of one pod should be running on each and every node of the cluster, irrespective of whether it is a scale up or scale down, then we would be using the daemon set. Okay, so typically if you are using any logging management or monitoring, you want to make sure each and every pod should run on each and every node. If that is the case, you can use daemon set. Let's ask ChatGPT when to use daemon set in Kubernetes. So in Kubernetes, a daemon set is a specialized result. This ensures a specific type of pod runs on every node in a cluster. Okay, so whenever you want to extract any metrics, whenever you want to run the logging agent like Fluentwait, Logstash, or Filebeat, or whenever you want to run any sort of things where you want to guarantee each and every pod of the set should run on each and every node, you will be using it. So for example, in case if the number of nodes increases, it doesn't mean, okay, when this guy deployed the daemon set, only 4 nodes are there, only 4 pods will be there. No, you scale up the cluster or scale down the cluster, those pods will be scheduling automatically. Okay, so this is what it is. All right, clear? Okay, so what are the logs that I'm referring is KGP. So these logs, what are the application logs that are coming through, I want them to be exposed. So for example, I would like to add something. I deleted this. You see the delete transaction, right? Now what I would like to do is 150. If you see this 150 grocery, it should be added. So I want to make sure each and every transaction that we make should be registered on the top of it. Okay. And you are aware of it. This is a get and this is the transaction, this is the response code. Okay, and this is the overall response time. Okay. And all these things I would like to extract. Okay, so these logs are already coming as per our intention, because if you look at this expense front end, and if you look at the Docker file, we are already using the nginx.conf, and the nginx.conf already defining how the log should be coming up. And that's the reason the logs are coming in a format that we want. So we are interested in these logs, okay, application logs. All right. So these logs needs to be pushed to ELK. So how can we collect these metrics and push to ELK? So we need to have a Filebeat agent to be deployed in the form of a daemon set. All right. So yeah, clear. Keep in mind, so you have your ELK stack, right? SSH2. Okay, sudo cat xc log stash Okay, if you look at this, in the past, we were mentioning, okay, the Elasticsearch is this. Okay, for the Logstash, we are saying the Elasticsearch is localhost, but this is okay, fine. And if you look at this, this is fine, but for the file bits, we need to say something different. Okay, so we need to change how it works, and also we need to change a fields.component. Okay, these are something which are added when you're using regular instances, but we need to change it. Okay, we need to tell something which Kubernetes offers. Okay, these are the labels when you are running on the top of the servers, but since it is Kubernetes, it would be changing, so you need to change accordingly. Okay, all right. So here you are already mentioning this is how authentication is happening, by the way. Fine. So next thing is each and every pod should be running on the top of it. For that, we already have a workload defined. So let's do it as a part of the automation. Let me get that. Okay. So any questions before I proceed further? Any questions? Am I audible? Can someone please confirm me?
Yes, Manoj, audible.
Are we clear?
Yes.
What did you understood so far in today's session? Can someone summarize me what are we doing? Come on. I know you guys know that. Just don't be hesitant. Just speak up. Anyone? Anyone? What are we doing? At least are we clear, by the way?
Yes.
Okay, all right. Okay, so I'm going to deploy a Helm chat. Okay, I'm going to deploy Helm chat to deploy this. Okay, there is a D1 set that is already in place. The only thing is, okay, all the logs, you need to remember all the logs of the containers that are running on the Kubernetes cluster, those logs are going to be saved temporarily on the top of var log containers underscore that. Okay, that's the reason I'm mentioning it. And next thing, you also need to mention what is your log stash output. Okay, so your log stash output is also something you need to mention. Okay, so let's try to mention that as well. Okay. What I'm thinking is, if I just a second, if I use route 53 expense.internal hosted zones, right now you only have one hosted zone. So if I use internal DNS record, it will not work. Okay, because this private hosted zone, okay, if you look at this, it will work only on the top of this particular VPC. Okay, if you want, okay. So I would like to use an IP address only, but for this to work, okay, all right. Let me do one thing. Let me simply use why to complicate. Let me try to use the IP address only. Okay, IP address of the ELK stack. So that means the file beats are going to know who is the log stash. So that's it. And this is a very important thing, how your beats come to know whose logs it has to metric. Okay, var log, container, star log dot, these are the logs it's going to install. So here are the commands to deploy this one. So I'll be doing it as a part of it only. So let me try to do it. Okay, so let me try to install it. So command this, install Helm chat. These are the two commands. Then file bits. Okay. Helm required. That's it. This is going to deploy the stack. Okay. Deploys file bit and Helm install file bit. You want to make sure. YAML. That's it. Okay, now this is going. So I want to make sure whenever I deploy it, I should get all of them together. Okay, that's the main idea. Okay. Done. Exit. I want to make sure. Telnet container. Telnet real world telnet Docker image. An image to see whether it works or not, whether I can SSH or not. Okay. Keep control. This is going to create a container deploy Kubernetes pod. Okay, so you get pods. Okay, so okay, exec-80. It's still creating. Damn. Okay, first let's see whether it's work or not. If not, I'll proceed accordingly. Do I get pull? Apply is going to deploy the beats on the top of my Kubernetes cluster. Let me show you that. Let's wait. Guys, if you have any questions, you can ask. Okay, so in 2 days, start applying for jobs. And second thing I want to talk is in the third project, okay, in the I think starting from Wednesday, we'll deploy one more project. On the top of the project, okay, we'll implement, we'll try to take everything, and then we'll try to track things. Okay, just like how in organizations you have your Jira board where people will create stories and will assign the task. Like that, I'll try to create everything on the top of the boards, and then I'll try to add comments. I'll close them. These are called as a GitHub issues. So we'll also use GitHub issues. Okay, tracking our automation. So let's wait before it comes up. Okay, this is expected. Okay, so this is a known bug, but rest of the things would be coming up. This I'll fix it. Okay, queue helm list, and if you want to see the status of it, it came up. Helm list. Okay, where is the file bit? Okay, interesting. Where is this? Okay, I get it. I'll just, because these provisioners, they would be running only history on this. So how are the provisioners? Let me install this because so that it is going to be triggered all the time. If not, only during the creation of the resource it comes up. Let's run it one more time. Again, you don't have to use quoted strings here. So the reason why I have used this is, okay, in case even if it is a failure, just proceed. Okay, that's the idea behind it. But though I have not mentioned this, why it is causing help install all the time is, okay, if you look at this Prometheus stack, I have mentioned it as all, oh, okay. Okay, file bit is fine. But helm uninstall ID is equal to this. Why it is installing all the time? It's a question. Okay, Prometheus stack is fine. Helm uninstall. Helm uninstall. Where did it come from? Next. Okay, what is the reason for this? Helm install boot ID. It's changing. What is changing all the time? Okay, we need to see this. Okay, I don't want this to be installing all the time. I only want my stack to be installed all the time. But let's see. Okay, let it come up. We'll improvise it. Perfect. Perfect. Okay, this time there is no change. Okay. Now the next thing is there is an issue here. It says not issue. So when Terraform upgrades from one version to another version, they try to avoid certain syntaxes and they call that as warnings, and down the line they are going to deprecate it. So they are not going to call that as mistake, but you, okay, as a part of your Terraform upgrades, you also need to make sure you just get rid of these warnings as well. Okay. So publish it. Perfect. Now Casey get daemon sets. Now you should be able to see a daemon set called as file beat. So KGP, you can see file beat, file beat. Okay, and this file beat pod, okay, is going to be right now only one, right? Now if the number of nodes increases, you will be seeing one more pod automatically. Okay, right now if the cluster is operating at 3 nodes, so each and every pod of the set, daemon set, will be running on each and every node. In case if it upgrades from 3 to 5, the new node will also be having that. Okay, this is called that one. Okay, all right, so let's try to get that. Now what's next is, and also as a part of the best practice, a minimum of 3 pods is required. Okay, in training we are just starting with 1 pod, but typically in organizations a minimum of 3 pods are needed. Okay. So file bit, it's coming up. So KLF, okay, you can see the logs that are coming up. It says error decoding JSON. Okay, what is that? Error decoding JSON, invalid character. What is this? So how can I mention the file bit? So where is this error coming from? Error JSON. JSON key is under root. Let me try to make it as, let's remove it. Okay, TF module EKS. Why these logs are coming up? I think is my code really going? On failure is equal to this. Because there is a change in the file. I get it. Okay, the reason why it is changing is whenever there is a change in the file. Okay, now there is no, now it's really working well. Okay, since there is a change in the file, it's working. And triggers I always mention as false. Fine, that's fine. So let's do it. And you can see installation failed, cannot use a rename. Elastic code already exists. Okay, fine. Helm list. Helm uninstall. Prometheus stack. File width quotes I removed, right? Why it's coming? Actually, there is some timing issue. Okay. File width, Nginx Ingress, perfect. Now where are my apps? Okay. Let's see whether my application is working or not. Okay. Now, now let's see. KLF. Okay, now those errors are gone if you see. Okay. What is the reason for it? Okay. Keep it this way, SSH2. There is a log error decoding JSON, invalid character. Perfect. This is the mistake. It is the reason. It clearly says badly formatted index. After interpolation still contains placeholder. This is a mistake. Okay. Okay. Read this error. Okay. So fields of component. Okay. It clearly says badly formatted index. Okay. Still contains placeholder. Fields of index. This event is not found. Okay. Containers are not offering those fields when it is offering the logs. So we need to find. So these fields are something that we have added for the app. Okay, if you come here and if you try to see this in the app, expense, roles, file B, templates. Okay, if you remember this, these are the logs. Okay, as a see, these are the logs, these are the fields of component. Okay, and these are the logs. Okay, that that we mentioned file bit should offer, but these logs are no longer offered by from the logs of the containers. Okay, so we need to find what are the logs that are offered by the containers on the Kubernetes. Okay, so we need to find it and we need to change it. Okay, so how do we know that? So here are the one. So in Kubernetes, this metadata is not needed. In Kubernetes offer some other data, we need to find out. Okay, go here. Okay, all right. So go on the internet and ask. Okay, so these are the fields that it is offering. So here we are using, okay. we are using fields of component, right? Likewise, we need to use Kubernetes pod name. Okay, pod name we should not use because it keeps on changing. Either you can use the workload name or we can also use the container name. So maybe container name and workload name, both of them are same in our case. You can use it, or we can also use pod IP, but pod IP also keeps changing. So I prefer to go with the name. Okay, so let's try to change it. Either you can use this or this. Let's see. Let's see what it comes up. Kubernetes.container.name. So we need to go to the log stash and we need to change it there. So go to the log stash. Where is tools? Where is tools automation? So here, I call them as EKS. Or just call it as ECS. Fields Kubernetes. Okay, so okay, if Kubernetes.container.name is equal to backend, done. Likewise, if Kubernetes container name is equal to front end, this is the log. Okay, Kubernetes container, done. And anything else? Okay, fine. That's it. So we have changed the pattern here. So we need to okay. Mm, okay. Ansible have a playbook. ELK, okay, done. Okay, so for this I need to go to tools automation. Do I get full? Done. Did I make the okay, done. Now let's try to run it. Okay, setup tools bash. Okay, bash setup tools.sh, and it's going to be ELK. So when you make automation, things are going to be seamless. Okay, that is the main advantage. We are focusing more and more on automation. Okay, if you spend more time on automation, operations will be less. That's it. Okay, and it says an undefined variable. Okay, we need to supply the token. If any vault underscore token. Okay. Okay. Set of icon tools.yml. Okay. Maybe hyphen. You know that starting ELK is going to take 1 to 2 minutes of time. That's right. Okay. Perfect. Let's see whether it's showing up anything or not. Perfect. Now you can see you don't see any sort of errors that were reported in the past. Okay. Now it's coming up. Now, let's go and see. Perfect. Can you see this? The logs are coming up. EKS pod logs are coming up. Okay, EKS file beat, but the name of the log is coming up as a file beat, which I don't want. Okay, I want it should be, whose logs are these? Exit. Okay, left. So see, there is no issues with the connectivity. Now logs are coming up. I'm very happy about it, but I want to change the name. How can I change the name? Kubernetes container name. Kubernetes container name is equal to front end. Kubernetes container back end. That's fine. Okay, perfect. Now things are coming up. EKS front end. Yes, this is what I want. Okay, if you come here and try to change it, you can see EKS front end and EKS back end as well. Okay, are coming up. Okay, so this is what I want. Okay, all right, now logs are coming up. Now what I want to do is I want to simulate the data. Okay, project the data. Okay, now each and every workloads are also coming up and you're also going to collect the logs of it. Okay, so any questions on this, anyone so far? Okay, so let's go ahead and try to create an index. Stack management. Create index. Indexes are coming up. So what I want to do is I just want to go to the discover. Okay, and I want to see the logs of my. Just want to create an index. Index. Okay, any questions, anyone so far? Any questions on this, team? Are we clear so far what's being covered? No, I need to create the indexes. How can I create the indexes? Discard index. Perfect. This is what I want. Okay. So whenever the logs I want, I can come here and select it. Okay, now you are getting this. Now what I can do is create a data view by saying this front end. Okay. Expense front end. Okay, and index pattern is EKS front end. Okay, done. Create the view. Done. Now we have the view. Now open the logs. I think this should be coming up with whatever we are expecting. Perfect. HTTP version. Okay, which is numerical. Perfect. 100 rows. And response time. Are we getting the response time? Okay, perfect. Response time is coming up. Response code is coming. Perfect. Okay, this is what I want. Okay, now response code I want. Now response code. Response time is also something I want. Okay, what else? What other fields are coming up? Response code, response transaction path. This is also something I would like to want it. Okay. And what other aspects am I interested? Okay, that's more than enough. Okay, so maybe we can also do one thing, message. Okay, that's it. Now we have created the view. Okay, EKS front end. That's it. Now we have all the information. Okay, this is very interesting. Now we got all the information of all our logs. Now if you see this, this is very short information, right? Okay, now we have only very lesser amount of data. Typically in organizations, okay, there is a concept called as benchmarking. Okay, so let me try to explain that. Benchmarking. Okay, so how do we know what is the capacity application that we build? Okay, typically you need to make sure you need to build an application that is scalable, but anything that scales will have a maximum limit. So once you build the application, okay, you do something called as stress testing or performance testing. Every time you release a new version, even if it goes from every minor version, every minor version or every major version that you upgrade, the application has to go through a performance testing there, where through performance testing, okay, okay, each and okay, just like for example, if you take an e-commerce application, okay, how people do shopping, how people make payment, how people try to browse the product, how people try to click the buttons on the top of your UI, like that, there are some simulating devices. Okay, so in the top of this benchmarking performance testing, JMeter is a very famous tool, performance testing tool. Okay, so this performance testing tool is going to simulate artificial workload on the top of our application, and it's trying to put a lot of load on it. During that load, we'll try to see how the system is scaling. Okay, how many requests are coming, how many response codes are there, and what is the traffic count, how many 500 errors are there. And during that performance testing, we'll also try to release a new version to see during that time if there are any errors that are coming up or not. Technically, you are doing a stress test to make sure whether your machine, your application is compatible with a 1 million workload or 2 million workload or 3 million workload. For example, yours is an e-commerce application which is across India, and you know that at any point of time 1 to 2 million workloads people are going to access. Let's say Black Friday sale, Christmas sale, Cyber Monday deal. So you have companies will have data assuming that okay, my application can be accessed by 3 million users or 5 million users or 10 million users. Based on that, they try to simulate the artificial workload, because you cannot hire 1 million users asking them to see, hey, how my product is working, which doesn't make sense. So we simulate the things by using tools. Okay, if we have more data, we can make more transactions. Okay, any questions on this, anyone? So that is called as a stress testing. Okay, so any questions, team? Anyone? Okay, you can also add the transaction time if needed. Okay, you can also add the transaction time just for seeing how it works, what it works, and all. So we can see what is the traffic, all these things. Okay, let's try to, since we have the information, let's try to visualize it. Okay, and since the data that we have added in the beginning itself, we know whether it is a string data, whether it is a what do you say, whether it is a numerical data and all. I think we already have graphs. Okay, if I'm not wrong, go to visualize. Boom. Yeah, there is something called as visualize library. I don't know where my old results went. Let me try to create a visualization. I'll choose lens. Okay. So here, so we need to stick to, okay, response time, okay, which is nothing but latency, error rate, and traffic count can be gained from logs, and that's the reason I'm creating it. What I'm gonna do is, this is expense. So done. So this I'll call it as expense front end. Horizontal axis is always timestamp. Vertical axis, let's see, count, what all records are coming up, response time is coming up, done. Now you can see at any point of time how it is reacting and all. That's it, should be good. Maybe I can call it as a rather count, just say average response time. And then again, our data is not continuous. So what I would like to do is I would like to just go with some, what do you call, any area graphs, and our data is incomplete because we haven't made any much traffic. Okay, it's just user. Okay, let me add some transactions. 150. Okay, 150 grocery, 120 gas. I'm just putting some load. Okay, and okay, it's done. Now we are also doing observability platform for the workloads that we deployed on the top of Kubernetes. Okay. Now, now missing values, I just want to call it as 0. I don't want dotted line. Straight, smooth. This makes sense. Okay, so it shows when transactions happen at any point of time. What is the average response time? You can see. Let me save it as latency average graph. Done. Now I don't have any library, so I'll just save it as save and go to the dashboard. None. Done. Now we have the latency. Okay, fine. Next. Next thing that I want to do is latency average metric. Then this time I just want to give a metric. What is the average response time? Not average response time, count. Response code. Count of response code. So I just want to see how responses are coming up. Done. Hmm. Actually speaking, a response code doesn't make sense. A response time makes sense. This is what it makes sense. Okay. Usually companies will have what is the P90 of what is the P90 response time. Okay. What is the P95 response time? So each and every company will have an LSL like, okay, my P90. Okay. No one uses average response time. Okay. Average speaks about whole, but P90 talks about how 90% of the requests are performing, how 95% of the requests are performing. Okay. So this is an average response time. To the library. Done. So at any point of time, we have the average response time. Next. No, response time, latency we have. Next thing is, we can go to what is the last value of the response code, latency line. Okay, that's it. So average response time, latency average graph, latency and response time, that's should. Latency line. It's always timestamp. Vertical axis is last value of the response code. This image is a 0. So we have the golden matrix of it. Done. So as a part of our metrics, we are interested about latency and then errors. How many errors are coming? Okay, anything above 300 is something that I'm interested. Okay, let's try to see it. What else? So traffic. Let's go with that. Perfect. So how many number of requests are coming? Typically that we can call that. Okay, data histogram. Count. Maybe you can call it as a count of records. Okay, and this can go as a legacy metric. So if someone asks, how do you know what is the rate of the response? So you can always share that. Okay. Traffic count. To the library. If you want to see at which point of time traffic is coming through, so traffic graph. I would like to interest about traffic graph. Okay, it's okay, count. Area makes more sense. Okay, let's call the missing value as 0 and interpolation as smooth. Done. Traffic flow, traffic graph. Okay, now we have the information about that as well. Next is error rate. Let's try to deal the error rate as well. How can I call it as a count? Error rate. Metric. Count. Okay. Count of records. Record. Code. Response code. Advanced. Maybe the error count. Advanced. Well, let's go with graph. Graph makes more sense. Okay, let's go with graph first, okay? With a line, error count. It's hard to feed. Response code. Filter by. Okay, maybe. HTTP or response time, response code. If the response code is greater than or equal to 400, then I would like to mark it as an error. Okay. So maybe greater than 100. Right now, I don't have any errors. So I don't see any of them. See, error graph. Done. Next is error count. Okay. Next is error count. Error graph. Count. Filter by. Code. Done. error code. Okay, format is equal to number, decimals. I don't want any decimals. Save it. Now, done. Okay, next visualization. Okay, what else I want? It is to RAM. So HTTP version, right? Count. What is the HTTP version that is being used? That doesn't add value. At any point of time, you can see count of records. Okay, done. Now I'll create a dashboard. Okay, done. Now I'll go to the dashboards. I'll create it as golden metrics. Okay, so add from the library. I just want to start from what is the latency. This one, error graph, error count, error response time. This. Okay, and then save it. Golden metrics, expense golden metrics. Okay, that's it. Now you have everything in place. So at any point of time, if you want to see any sort of information, you have everything handy. Okay, then latency line, error graph, error count. Error count is really 0 because you really don't have errors. Okay, to prove whether there are any errors or not, we'll also do some testing. Average response time. There is no traffic, by the way. In last few minutes, we'll try to simulate some load. Okay, then only you can really prove traffic graph, traffic count. Request count. Apply and close. Okay, now we'll put some load so that you should get the information. Okay, you can see. All right. Perfect. Now what I want to do is I have all the metrics. Okay. So now whenever I want, I just want to come here and just select this. I should get all the information in a single shot. Okay. That's the main idea. But what I can do is, how can I simulate traffic? How can I simulate traffic? Okay, there is a load test script. Okay, let me get that script for you. So I have some artificial load test simulation. Let me try to show that. Okay, there is a load generate script which is going to generate the load for you. Can someone confirm, am I audible? Anyone, can you confirm me, am I audible? Okay, there is an artificial script which is going to do that. So what I'm going to do is just tools, right? Expense load gen. Okay, so this is the script. Now what I have to do is go to the B58 tools automation. Just like a normal user, I'm gonna come here, load gen, expense load gen. Okay, so I'll just simulate the traffic. Okay, curl. Okay, curl this sudo bash. Okay, and you need to supply this URL is equal to first one, which is the argument, and the argument is expense.cloudapps.today, right?
Manoj, we could see this elastic screen
Oh,
only.
about now?
Yeah, now we can see.
Which screen were you seeing in the past?
That elastic graphs.
Okay, all right. So let me see. Let's see Cloud Apps expense.cloudapps.today. Not internal. Copy this. Let's try to simulate some artificial load. Okay. Okay. Sudo bash load gen. Okay, now it's going to simulate a lot of traffic on the top of it. Okay, so it's a very simple bash script. All it's doing is it's just trying to make an artificial simulation. This is something which will be given to you by your developers or by your performance testing team. Okay, and if you look at this, it's going to put a lot of load. Okay, so let me see whether it's showing up any data or not. Save it. Can you see this? You can see a lot of latency. So traffic, where is traffic? Traffic. Can you see this, the number traffic count, guys? So you can come here and you can mention the refresh interval, absolute. Now, you can come here and see. Now you can see why traffic is not coming now. Bash login. Okay. Why traffic is not showing up? Edit the visualization, expense, error count. Mhm. No, not response code, response time, right? Okay. Cancel. Why the other data is not coming up? Error graph. We're done. Last 15 minutes. Why data is not showing up? Let me do some transactions. Can you see this, guys? Guys, can you see? These many transactions were made by, okay, this guy. During this time, if you want to see how it's performing, I don't know why it's not popping up. Okay, create visualization. Not create visualization, go to the dashboards. Delete this. I don't know why it's not working. Okay, add from the library. I just select response time, this one, this one, this one. Just save it. Okay, I don't know why it didn't work in the past. Okay, if you see this, there are no errors. Okay, there are no errors at this point of time. And this is the average response time. And error graph is absolutely nothing because there are no errors on this. Okay, as this is not much robust application, you don't see the errors much. Okay, there is no much complexity on this. It's just add a record. Okay, and you can also see what is the latency. Okay, and how messages are coming at. Okay, and you can also see what is the traffic. Okay, how traffic is coming up. Okay, what is the traffic count, and we have covered all the important metrics. Now during this time when this load test is going on, okay, you can refresh it. Okay, 3346, okay, 33463809. You refresh 3945. Now during this time, I'll try to make a deployment. That means I will be moving from one version to another version. Okay, so I'll be moving from one version to another version. So when a release is going on, okay, when a version is live, during the change time, if we make a release, for example 002 to 0.0.4, okay, how it will work. Okay, is it going to see any downtime or not? Okay, is also something that I would like to see. For that, what I would like to do is I'll just try to make a dummy push so that it is going to make a release. I just want to see how the behavior works. Okay, I just want to make a new release. During this time, when a new build is going on, I want to see how the behavior pattern is. Okay, so let's see. Go to actions. I know that there is a build has been triggered. So let's see how it works. Okay, so I don't see any errors so far. Okay, so if you see this, okay, 5,000. 5215 transactions. Okay, so I'll come here and try to refresh. See, can you see this 5351? Okay, you can also come here and see. Refresh 5351. Okay, these many transactions were done. This is called as artificial, okay, simulation. All right, now let's see, I'm making a release. During that time, if I see any errors or not. Okay, average response time is 003, which is very, very good. And right now the errors are none. Okay, so let's see how it works. I am trying to make a release. So let's see, it's still uploading. So that means, so let's say here you have a pod and it is running version 1, which customers are accessing. Now you're creating a new version 2. During this time, okay, how Kubernetes works is if version 1 goes from version 1 to version 2, okay, a new pod will be created first. Okay, and then the old pod will be deleted. So technically you should not see any 0 to none downtime. Okay, so let me prove that to you. And that's the reason I told you to go with 3. Okay, you can clearly see a deployment is going through. Okay, authenticating, and it already made a deployment. Okay, now you can also see during this time if there is any issues or not. Still there is no issues here. Okay. So the reason why you didn't see any issue is because we are going with rolling update. Okay, new pod comes up, then only the old pod will be destroyed. Okay, now you can, if you make a refresh, you saw error count is 3. Perfect. This is what I want. This is what I want. Okay, so this is what I want. Come here. Okay, if you see this, okay, there are 3 errors. Okay, there are 3 errors, and the reason for this is you are running it with a 1 pod. Now, what I would like to do is expense backend, right? Expense backend, expense app. Inside the expense helm, what I would like to do is I would like to make it with 3. Let's see. Now, this is backend, right? So backend minimum replicas, I would like to mention it as a 3. Okay. Now I'll try to I'll try to make a release. Okay. So this time what I would like to do is scale deployment expense hyphen front end or backend. We are trying to make update to backend, right? Okay, now you can see 3 pods. Okay, now I'll try to make a new release. Okay, so see the expense helm. Now I am operating with 3 pods. Okay. Now let me go to the backend. Okay, and I'll just try to make some. Okay, release now. This time I'll call it as 008. Okay, now this time it's going to go for a deployment again one more time. 53 version. Come here, version 008. Now this time, okay, you should not see any errors. Okay, let's see. So this time what I'm gonna do is I'll just wanna come here and say last 5 minutes. Let's see. Okay, and let's wait. During this time, I would like to run my script. So again, it's going to simulate a lot of load. Okay, just a proof. I delete everything. It's running. Let's wait. Done. Let's wait. Okay, now during this time, a release should happen, right? So let's see, uploading the image, scan and decide. Let's wait for it. So if you have an observability platform like this, you can see the insights of your application. Okay, that is the main reason we are interested about it. Okay. So you got the response time, average response time is 0. You can see, refresh, the error count still remains the same. Now you can see the dev deployment happened. Guys, can you see this? The dev deployment happened. So during the deployment as well, you didn't see any errors. If you see this, the error count still remains the same 3. Okay, which happened during the first time. Now, if you see, there are no error count. So that's the reason. Okay, if you look at this, how it happened was, okay, so there are 3 pods. I think you know this already. There are 3 pods of front end, okay, which are running version 1. Now, what I did, I told to deploy version 2. Now, what happened was immediately version 1, okay, new pods of version 2 created. New pods of version 2 created. Okay, and once they come to the ready state, then it has destroyed the old pods. Okay, that's the reason it achieved near 0 time. deployment. This is called as a rolling deployment. Okay, clear? Guys, clear? So this is what I would like to prove. Okay, all right, clear. Perfect. That's it. And so tomorrow we would be starting from tomorrow, we'll be implementing a very, very, very big application. Okay, so starting from today, you can start applying for jobs. All right. So whatever the topics that I have promised, that I have delivered everything. Whatever I am going to teach going forward is a bonus. Okay, I want to be very, very clear on it. Okay, so usually the training is on the top of one project. We'll implement the other project, but we are also going to do the project 2 as well. Okay, whatever technically we are done with the course. Okay, but for the next 1.5 months, I am going to do the same thing on the top of the project 2. People who are interested, please do join. Okay, this is going to be very, very interesting. Technically, you are open to start applying for jobs, but out of passion, I would like to do one more project. Okay, and the project is Instana project. It is an e-commerce based project with 11 architecture. Okay, this is something we would like to implement it to the core, which will have a lot of use cases. Technically, December you have, I mean, the interview calls are going to be very, very less. So that's fine. Please feel free to attend this. It's going to be very, very, very interesting. Okay, it is going to have 11 components and we are going to do everything. Okay, it's a very big project. So since we know Terraform, Ansible, everything, it will be very, very quick. Okay, that's for today. And yeah, that's all. If you have any questions, you can ask. Any questions, anyone? Any questions? Any questions? Am I audible? Can someone please confirm me?
Yes,
Okay.
Manoj.
Okay, so technically you are good to start applying the jobs. Okay, the project 2 is something which will have a lot of use cases, so which I'm interested to go from. Okay, that's for today. Please take some time, please start practicing, and that's for today, guys. Okay, thank you. Signing off for the day. Bye. All right, signing off. Bye.